In this lesson, we introduce the concept of the standard form of a linear equation, and we'll start with an example problem that suggests an equation in standard form. Raisins cost $3 a pound and peanuts cost $4 a pound. You bought a mixture of raisins and peanuts that cost $32. How many pounds of each could you have purchased? If we let x represent the number of pounds of raisins and y represent the number of pounds of nuts, then we can write an equation to calculate how much a certain amount of raisins and a certain amount of peanuts cost. So we would take the price per pound of raisins times the number of pounds of raisins plus the price per pound of nuts times the number of pounds of nuts that you bought. And we want that to equal 32. This equation is an equation in standard form. So now let's have a formal definition of standard form. A standard form equation is one of the form a times x plus b times y equals c, where a, b, and c are integers. So let's see some examples of equations that are in standard form. First, the one that we just did, 3x plus 4y equals 32, is an equation in standard form. 9x minus 12y equals 18 is also in standard form, even though this is a negative. That's because if we need to, we can write it as 9x plus negative 12y equals 18. So we'll say that these two are the same equation and both of them are standard form. Now here's some equations that are not in standard form. 3.5x plus 4.5y equals 32. This is not in standard form because the coefficient of x and the coefficient of y are decimals. Here's another one. 1/2 x plus 3y equals 10. This is not in standard form because the coefficient of x is equal to 1/2. Another example is y equals 2x plus 7. That's not in standard form because it's not something times x plus something times y equals a number like 7. Now here's an example of something that is in standard form. 2x minus y equals 7. Now it may look like there's no coefficient of y, but there really is. It's negative 1. One last example of something that is not in standard form. Y equals 1/2 x plus 2 minus 3. Once again, it is not written in the same form as we see it at the top here, a number times x plus a number times y equals c. First, let's see how to graph an equation in standard form. We'll take the equation 10x minus 6y equals 30. The method that we're going to use is to find the x-intercept and plot that on our coordinate plane. Find the y-intercept and plot it on the coordinate plane, and then use those 2 points to graph the line. Now as a reminder, the x-intercept is the value of x when y equals 0. And we find it by taking the equation and setting y equal to 0. We just make it 0, and then we solve for x. So we'll take our equation 10x minus 6y equals 30, and we'll write it as 10x minus 6 times 0. That way we're making y 0. We say that equals 30. So now we have 10x minus 0 equals 30. And you can see that x equals 3. So our x-intercept is 3, and we can write it as either 3 or as the point 3, 0. And this is the point that we're going to plot. Let's find the y-intercept. The y-intercept is the value of y when x is 0. So we'll take the same equation, we'll make x 0, 10 times 0 minus 6y equals 30. And then we'll solve for y. Well, 10 times 0 is 0, so this is 0 minus 6y, so that's just negative 6y equals 30. And if we divide both sides by 6, y equals 30 over negative 6, which is negative 5. So we say that the y-intercept is negative 5, or it's the point 0, negative 5. Now let's see how to graph that. We saw that the x and y-intercepts were 3 and negative 5, and we find the x-intercept, find the y-intercept, and plot them. So we plot the points 3, 0, it's right here, and the point 0, negative 5, that's right here, and then we use those points to graph the line, and we just use a ruler and connect them, and we've plotted our line. Now here are two forms of standard form equations that are a little confusing to graph, but in a way they make sense, so I'll try to help you make sense of it. Let's take the equation x equals 2. Now what this equation says is that x equals 2, but since y doesn't appear, it does not matter what y is. So first, let's make a table of values where x equals 2. So here's x, here's y. So x equals 2, x equals 2, x equals 2, x equals 2. This says that x always equals 2. If x equals 2, y could equal negative 1. If x equals 2, y could equal 0. If x equals 2, y could equal 1. If x equals 2, y could equal 3. All of these are possible points. This equation tells us that the x-coordinate is always 2, but the y could be anything. Now let's go to the coordinate plane. We'll plot these points, 2, negative 1, 2, 0, 2, 1, and 2, 3. You can see that all of these points lie on a vertical line. So when we graph x equals 2, what we're going to do is graph that vertical line. So we'll just label it. This is the line x equals 2. Let's graph another one. Let's graph x equals negative 3. So once again, we can think about this by making a table. And when we say x is negative 3, x is always negative 3. Can't be anything else. And we can pick values of y. As long as x equals negative 3, it's the point is on the line. So if x equals negative 3, y could equal negative 3. Y could equal 0. Y could equal 2. Could equal 1. It could equal negative 4. Let's plot those points and see where they lie. Negative 3 would be right here. Negative 3, 0 is here. Negative 3, 2. And negative 3, negative 4. Once again, you'll notice that the points all lie on a vertical line. So the graph of the line x equals negative 3 is a vertical line. Now let's take a look at graphing horizontal lines. Let's consider the equation y equals 3. Now in this case, we're making a table. We'll make the same table as we did above, except this time y always equals 3. X can equal anything, but y has to equal 3. So x could equal 0, 1, negative 1, 4, or negative 2, or anything else. Let's plot these points and see where they lie. So 0, 3 is right here. 1, 3. Negative 1, 3. 4, 3. And negative 2, 3. So you see all of these points lie along a horizontal line. And when we graph this, we would graph that horizontal line. Let's try another one. Let's try y equals negative 1. Again, we'll make a table, x and y, and we will make y equal to negative 1 at all times for all of our points, and then we'll pick other values of x, negative 3, negative 5, 2, and 0. Let's plot those points and we'll see where they end up. Negative 3, negative 1, negative 5, negative 1, it's right out here, 2, negative 1, and 0, negative 1. So you can see once again all of the points lie along a horizontal line, and we can graph that line just by drawing a line through those points. We have two special lines. The x-axis is the line y equals 0. All of the points on the x-axis have a y-coordinate of 0. This is 1, 0, 2, 0, 2.5, 0. And on the y-axis, this is the line x equals 0. And every point on the y-axis has an x-coordinate of 0. So just to be sure, this is the y-axis, and its equation is x equals 0. And this is the x-axis, and its equation is y equals 0.